For decades, software development has lived by a strict, comforting rule. If you write the logic correctly, the machine will do exactly what you tell it. Traditional code is deterministic. It runs on rigid rules and produces predictable, binary outcomes. When that kind of system fails, the problem is usually obvious. A button stops working, a web page crashes, or a database refuses to load. The machine simply stops functioning until a human fixes the broken gear. Generative AI replaces mechanical reality with probabilistic systems, generating unpredictable outputs based on statistical patterns. The danger is a model can sound confident while being completely wrong, inventing facts and presenting them with a polished structure exactly resembling the truth. A major trap for development teams is treating these conversational models like traditional software components. Slapping a sleek interface over unpredictable logic without adding safeguards leads to shipping hallucinations to users at scale. Because the nature of the technology has changed, the job description has to change with it. A developer's responsibility now requires actively anticipating, managing, and mitigating unpredictable outcomes before they ever reach the public. Building responsibly with AI starts before a single line of code is written. The first and most critical question a developer must ask is whether a specific problem actually requires generative AI in the first place. Large language models are highly effective for open-ended tasks that require creativity, summarization, or prediction. But if a workflow relies on strict facts, it is often better served by a standard database, ordinary logic, and a quiet afternoon. When teams do choose to implement AI, they have to overcome the illusion of competence. It is dangerously easy to mistake a model's conversational eloquence for factual accuracy. Developers must build strict structural barriers. As raw AI output passes a verification layer, it splits, separating generated text from verified facts. High-stakes environments require tighter controls. Programming confidence thresholds physically prevents the AI from improvising when it lacks data for a safe answer. True development efficiency is measured by the structural barriers you architect to prevent confident nonsense from reaching your end users. Beyond accuracy, generative models introduce entirely new security vulnerabilities. The massive, open-ended nature of prompt windows and context memory creates an expanded attack surface that traditional application security was not designed to handle. Developers must actively defend against these novel threats. Attackers use tactics like prompt injection, disguising malicious instructions as regular text, to manipulate automated workflows and force the model into executing unsafe actions. There is also a strict privacy imperative. Because these systems often log inputs for memory or analytics, developers have to minimize the data entering the model and actively scrub personal identifiers from prompts before they are processed. Then there are the quiet failures. AI bias rarely triggers a system crash or an error code. Instead, it systematically and silently marginalizes specific demographics, producing stereotyped results or uneven recommendations without sounding any obvious alarms. To catch these uneven failure patterns, teams must perform active, continuous fairness testing. This involves running diverse inputs across various cultural contexts to identify and tune out harmful behavior before the software goes live. A seamless interface that masks privacy leaks or systemic bias is a well-designed liability. Presentation cannot mitigate the underlying risks created by the model. Ultimately, the deployment of generative AI operates on one definitive rule. Ethical and functional accountability cannot be outsourced. You cannot pass the responsibility off to the underlying language model or the third-party vendor that trained it. If a system causes real-world harm, claiming that the AI made the decision on its own is an entirely unacceptable defense for the developers, the legal teams, and product owners. The people who design and launch the system own the outcomes. The standard for a mature generative AI application is a system built with the baseline assumption that it will eventually fail, drift, or make a mistake. This flowchart illustrates how the architecture itself must rest on strict structural pillars. The system must be auditable, so decisions can be reviewed, interruptible, so bad behavior can be abruptly intercepted, and recoverable, so there is always a safe fallback path. End users also need to be clearly informed when they are interacting with an AI. They must be provided with direct, visible channels to report problems, appeal decisions, and have human operators correct automated mistakes. Generative AI offers an incredible illusion of magic and speed, but when you strip away the polished interface and the automated workflows, the ultimate tangible product a responsible developer is actually building is human trust.